Greetings from the third field trip stop in our series of virtual field trips. Today we're coming to you from the Interstate 82 Manastash Ridge viewpoint. Behind me is Interstate 82. It's the main highway between Ellensburg and Yakima. And beyond that, the entire Kittitas Valley laid out before us. It's beautiful up here. It's a little warm. We've got the Mount Stewart in the background. And as nice as all of this isn't actually what we came to see. We've got some outcrops that we're going to head over to right now. Okay, we're over here at the rock formation that we actually wanted to come see. And the first thing I want to point out are these structures right here. Pillow basalts. It's basalt lava rock. This is all basalt lava rock, but this part has a really interesting structure. You can see these round shapes. There's one up there, there's one, there's one. There's these round shapes all over. And around the outside of these round shapes, we have this yellowish clay. It's a yellowish clay mineral. It's really dusty. These basalts, these pillow basalts, are a very specific structure that you get when lava rock is erupted underwater. If you watched the Columbia River Basalts lecture video, I explained in great detail exactly how these pillow basalts form. But this is the first thing we want to look at. We see that we have a big basalt outcrop, and down here at the bottom part of it, pillow basalts. Alright, this is the layer of basalt below the sandstone, or at the very top of the layer of basalt below the sandstone. And the thing that we want to point out here are all of these holes. Those are vesicles, trapped gases that never escaped the lava when the lava cooled. And so it left all these holes, making it look like Swiss cheese. Cut. What we're seeing right here in the middle of our sandstone is a very thin layer of pebbles, which, as Katie pans the camera up the hill, you'll see is continuous throughout the sandstone, that thin layer of pebbles. All right, here we have the whole outcrop. At the bottom, we have a layer of basalt lava. In the middle, a white sandstone. And at the top, another layer of basalt lava. Now, as I'm standing facing you right now, that way is north, and that way is south. We gotta remember some of our relative age dating principles. Was this thing like that when it formed? What do we see inside the sandstone? We see little layers. Those layers are flat right now. But were they flat when they formed? Think about original horizontality. We know that layers of rock form flat. If they're not flat now, something happened. So pause the video, grab your protractor, and tell me about what angle this stuff is to horizontal. The bottom of your screen is horizontal. And then think about what might have caused those ripples, those layers in the sandstone. What might have caused those layers to form? They weren't flat when they formed. We've got a car coming up behind me now, so I'm moving out of the way. There's another car coming, so I'm staying out of the way. back in the road, playing in traffic. Excellent. So we want to think about the boundary between the basalt and the sandstone. That's the contact between these rock units. 3 rock units. Basalt, sandstone, basalt. We have contacts, and those contacts are what was originally flat. So, what happened to make the sandstone? What happened to make those layers inside the sandstone? Part of that is you thinking that through and figuring it out. We're going to look at a couple of details up close to maybe help you with that a little bit, and then you'll go through the questions to guide your thinking. I think that's about it.